So like I said, we're going to start with 4G today. 4G and 4H are solving systems of equations using algebra. And so 4G is the substitution method. This is honestly the method that I use myself. 4H has to do with something called the elimination method, okay? So in your homework, or I shouldn't say your homework, or more so on like the quiz and the exam, you want to be able to practice both. If the question says use this specific method, I will be looking to see that you're showing those steps. But as always, I want you to do what works for you. And so if graphing them works for you, if solving them algebraically works for you, that's fine. But if there's ever a question that says specifically use this method, then we are trying to assess, like, do you know how to use that method? And that is going to be the method that I am expecting you to use. So just keep that in mind. But like I said, today we're going to focus on the substitution method. If you ever want to check your work, as usual, graph the lines in Desmos and you can see what happens with them. Okay. So let me share my screen and we will get going. All right, so you'll see here, I've got some instructions at the top of the page about how you want to, or some steps you can take, excuse me, to solve using substitution. And really the idea behind substitution is you're isolating one variable in one equation and plugging that amount in for that variable in the opposite equation. So again, the verbal description of how the substitution method works is, you're going to isolate a variable in one of the equations, like I said. You're going to substitute the result from that first step in for the same variable in the other equation. You're going to solve a new equation for the remaining variable. And then you're going to substitute the solution from step 3 into either of the original equations to solve for the other variable. And you're going to check your solution in both equations. So what does that actually look like? Well, remember, we can have 3 different possible solutions. We talked about these when we were graphing the lines, okay? The one solution, that's our ideal one, right? That's where you get an ordered pair, and that's where those 2 lines intersect. You can get no solution, and this is where the lines are parallel, right? Parallel lines have the same slope, and they're, when we're solving this algebraically, we get something called a contradiction, right? And it's where like we're solving and suddenly we get something like 0 equals 1. And we're like, no, it doesn't. These are very different values, okay? And so if we were to be solving this algebraically and we get something like that, then that would lead us to say, oh, these are parallel lines, there's no solution. Or you have the last idea, which is where you have an infinite number of solutions, right? And this is where there's the same line. And this, if we're doing it algebraically, then we get something, a redundancy, where you would come up with something like 0 equals 0, 1 equals 1, 2 equals 2. And you're like, well, yeah, I already knew that to be true. But what that tells us is, again, what's happening here is your variables are completely falling out. And you're going to get that redundant statement, and that will lead you to go, oh, wait a minute, there's an infinite number of solutions because these 2 equations are just the same line. So how does this work? Like, what are we doing here? So remember, the first step says, look at your equations and isolate a variable in one of them. When I look at these 2 equations, my first one is x plus y equals 5. And the other is y equals x plus 3. Well, I already have a variable that is isolated. Y is isolated in the second equation. So if y is equal to this stuff, that means, because we're solving a system, we're going to look at what happens when y equals that stuff in the first equation. So I'm going to take x plus 3, and I'm going to plug it in for y, or substitute, hence substitution method. I'm going to substitute x plus 3 in for y in the first equation. If I do that, I get x plus, and then I'm going to write x plus 3. I'm writing this in a different color just to remind ourselves we substituted that value in, and this is equal to 5. Once we me write this 3 a little nicer. Once we write this all out, then we're just going to use our standard steps to solve equations, which is from here, we're going to combine like terms. So you can see we have 2 x's. So together, these are going to make 2x, and then just plus 3 equals 5. We are going to subtract 3 from both sides. So we're just using our algebraic steps now. We're going to divide by 2, and I get x equals 1. So once I have solved for one of the variables, I'm going to look back at the 2 equations, the first 2 equations that I have, these 2 right here, and I'm going to say, okay, oh, let me let my board cut out. There we go. I'm going to say, okay, I need to solve for y. I can plug 1 in for x in either of those. But if I'm solving for y, it makes more sense to plug it into the second equation because y is already isolated there. So I have y equals x plus 3. I'm going to take this value of 1 and plug it in for x. And then I'm going to solve. So I'm going to have 1, y equals 1 plus 3. Combining like terms, I'm going to have y equals 4. So then I have one solution, and that solution is the ordered pair 1, 4. Now, you can check by plugging that back into both equations to make sure it's true. Also, if we go into Desmos, let me share my Desmos screen with you. If we go into Desmos, we can type those equations in. Remember, my first equation was x plus y equals 5. So there's that equation here in red. And then if I graph the second one, y equals x plus 3, I'm going to be looking for the point where the red line and the blue line intersect, which is this point right here, right? So if I hover over it, I can see that the intersection there is the point 1, 4, which matches what I got algebraically, and so I know that I solved this correctly. So we're going to go to the next page. And looking at number 2, I want you to try that one yourself. So send me your solution. If you're just going straight to graphing it, that's not going to help you out, right? You need to solve this algebra. You need to practice the steps, but then, like I said, you can check your answer by solving it in Desmos. Let me share my screen. I realized I still had Desmos showing. Hold on one second. We'll go back to that. So in case you don't have the problems in front of you. Again, you're solving number 2, and that's the one you're going to send me the solution to. So remember, we need to isolate a variable. Again, in number 2, we actually already have one isolated, right? Y equals 2x minus 5, which means y is isolated. So we have what y equals. So we're going to take this stuff and we're going to plug it in for y in the second equation. So plugging it in, I'm going to have 3 times, and so I'm plugging this up in for y. So it's going to be 2x minus 5. So I'm replacing y with that stuff, but we're not dropping the 3y, right? We're not dropping 3 times what that value is. So when we plug it in, we've got 3, and then 2x minus 5 takes the place of y, and then minus x still equals 5. So oftentimes you will have a value that's attached to that variable, right? A coefficient that when I replace the variable, we have to then distribute that coefficient to what's inside. So I'm going to take 3 and multiply everything that's inside by it. So I'm going to have 3 times 2x minus 3 times 5 minus x equals 5. 3 times 2x is going to be 6x. 3 times 5 is going to be 15 minus x equals 5. So remember from working on solving equations before, I have 6x here minus x here. So together, those are going to make 5x. We'll bring down the minus 15, and that still equals 5. And then we're going to now solve for x, right? So we need to add 15 to both sides. Moving up over here. Let my board catch up. I've got 5x equals 20. Divide both sides by 5. And x equals 4. And so I have what x equals. I still need y. So we can go back to this original equation because of the fact that we already had y isolated there, right? So I'm going to say, all right, y equals, and now 2, I'll plug that 4 in for x. And so 2 times 4 is going to be 8. 8 minus 5 is 3. So between those two values, right, that x equals 4 and that y equals 3, we get the solution of 4, 3 as our final answer. So questions about that one? All right, so if we look at number 3, so you'll notice in 3, we have A's and B's instead of X's and Y's. When we think about ordered pairs, they're always going to be in alphabetical order. So our answer is going to be in an ordered pair that is A, B. Okay, so it's okay that we don't have X's and Y's. It's still whatever variables you have, when you solve for them, to solve for the system, or whenever you solve the system to find the solution, you're going to be writing that solution in alphabetical order in terms of your variables. So like I said, in number 3, we have A's and B's. Therefore, our ordered pair would be A, comma, B. Now, unlike 1 and 2, we don't have a variable that's isolated here, right? We have A minus B equals 6. And 3a minus 4b equals 18. I always look for isolating the easiest variable. So like when I look at equation 1 or equation 2, equation 1 is more simple, and therefore that's the equation I'm going to use to start off with in terms of isolating a variable. You can do it with equation 2. It's just not as nice, right? You're going to end up getting fractions and all sorts of stuff. So looking at equation 1, that's the easier equation to use. So if I have A minus B equals 6, the easiest step is to isolate A here, right? We would just add B. So adding B to both sides, we'll bring that A down. And it's equal to 6 plus B. If you're like, Aaron, I can't have my variable second, you can write B plus 6. That's fine. Doesn't matter to me. So from here, we now need to substitute this 6 plus B or B plus 6, whichever you're more comfortable with, in for A in that second equation, right? Because we had to isolate a variable to be able to substitute it in for that other equation. So when we do that substitution, we're going to have 3 times 6 plus B minus 4B equals 18. So we'll have to distribute. We get 3 times 6 plus 3 times B minus 4B equals 18. So continuing, 3 times 6 is going to be 18. 18 plus 3B minus 4B equals 18. Combining like terms, I'm going to have 18 plus negative 1B equals 18. You can write that as just 18 minus B, that's fine. I'm reminding myself that there is a value in front of B because oftentimes people forget to divide by that negative 1 at the last step. And so I'm just using that negative 1B to remind myself, oh, wait, there is something here that I have to deal with. So we'll subtract 18 from both sides. And we'll bring this negative 1B down. And 18 minus 18 is 0. And therefore, you might be tempted to be like, oh, well, this isn't an answer. It is an answer. We're just going to divide both sides by negative 1. And I get B equals 0. And that's an okay answer. It's fine for one of our variables to equal 0. We would have had an issue if at that step where it said negative 1B equals 0, if that had just said negative 1 equals 0, then we would have had a problem. But we were able to solve for the variable. It didn't get knocked out. So we have a solution. Now, when we look at where we're going to substitute the 0 in, we actually have 3 equation options. I can substitute it in here, or in this equation. And the reason why I like that last one, that A equals 6 plus B, is because I'm solving for A, and I already have A isolated. So I'm going to take this B equals 0 and plug it in here. And so I get A equals 6 plus 0. Therefore, A equals 6. So my solution is the point 6, 0. Okay, before I go over numbers 4 and number 5, we're gonna go to the next page, and I want you to try number 6 on your own. Okay, so we do get a solution here. Nice numbers, okay, meaning they're nice whole numbers, unlike one of the other ones on here. So we're gonna do number 6 on your own. Send me your answer in a direct message, and then I'll go back and go over numbers 4 and 5. Okay, so like I said, I'm always looking for the easiest variable to isolate. And when I look at number 6, X jumps out to me. They're not always going to be super easy. And I've got, we'll look at some other examples later when it's not fun. But right now, X, easy one to look at. So I've got X minus 2y equals 5. So I'm going to isolate X by adding 2y to the right side. So I get X equals 5 plus 2y. I'm now going to take this stuff and plug it in for X in that second equation, right? So doing that, I'm going to have 2y minus 3 times 5 plus 2y equals 1. Once I substitute, easy place to make a mistake here. So we can see that it's 2y minus 3 times that stuff. Remember that negative is going to be distributed through both times. It might be helpful for you to rewrite this as 2y plus negative 3 times 5 plus 2y, because I'm just adding numbers on the end for some reason. Because we need to make sure that both terms they change signs, right? So distributing that negative 3 through, I'm going to sneeze. We're going to have negative 3 times 5, giving us negative 15, and negative 3 times 2y, giving us negative 6y. We now can combine our like terms, right? I've got 2y and negative 6y. And combining those, I end up with negative 4y plus negative 15 equals 1. Moving up here, I can isolate my negative 4y by adding 15 to the right. Again, I'm adding 15 because it's plus a negative 15. So to undo that, the opposite is plus 15 or positive 15. So I end up with negative 4y equals 16. Divide both sides by negative 4. And I get y equals negative 4. So we've solved for one variable. We need to solve for the next. Again, we have 3 options for equations we can choose. We can choose 1, 2, or our new equation 3. Like last time, that new equation is the easiest one to deal with because I'm trying to solve for X and X is already isolated. So I'm going to do X equals 5 plus 2 times negative 4. 2 times negative 4 is going to be negative 8. And 5 plus negative 8 is going to be negative 3. So now I can write my solution as the point negative 3, negative 4. All right. So going back to number 4, we're going to look at 4 and 5, hint, are going to be those weird solutions. So let's look at that. Let's look at what that looks like from an algebraic standpoint. So we're going to do number 4. So I already have a variable isolated number 4, so that's nice and helpful. So we have X equals 2y plus 1. So we're going to take this stuff and we're going to plug it in for X in that second equation. So I'm going to have 3 times 2y plus 1 minus 6y equals 2. You might be able to see how this is going to kind of come together weird. When I distribute that 3 through, I get 3 times 2y, which 3 times 2y is going to be 6y, plus 3 times 1, which is 3. And then we still have that minus 6y equals 2. So positive 6y minus 6y, those are going to cancel out, right? So what I'm left with, right? So these, they cancel each other out. So I'm left with just 3 equals 2, and that's not true, right? That is not a true statement. This is a contradiction. And therefore it tells us that we have no solution And if we have no solution, when we get a contradiction, that's because they are parallel lines. In your homework, the options are, you have a solution. So it says the solution of the system is, and then you would put your solution in, or you have infinite number of solutions, which is, remember, when they're the same line, or you have that final option that says there is no solution. So this would be a no solution type situation. So if we look at number 5, that's going to be an infinite solution type situation. Again, like number 4, we already have a variable isolated, so super helpful, right? And so all I have to do is take this stuff and plug it in for y, okay? So when I do that, I'm going to have 6x minus 2 times 3x minus 1 equals 2. Remember, it is 6x minus 2 times that stuff. So like we did before, let's change that to a plus -2 times 3x minus 1. It's the little things like this that are going to make it so you might make mistakes. So remembering that we're changing everything, all the signs inside. So distributing that through, I'm going to have 6x plus -6x, and then -2 times -1, or -2 times -1 makes it a +2. So the 6x plus -6x, those cancel each other out, right? And all we're left with is 2 equals 2. And we're like, well, yeah, we knew that already. That is true. But this is a redundancy, right? So when we get something like this, this needs to trigger our brain to go, oh, these are the same line, and which means there's infinite solutions. Infinite. Let's actually spell this right. And remember, the infinite solutions is going to come with that set notation. So it's going to be something like, remember, it's the set of all x, y's such that they are on this line, right? Like they satisfy that equation of 3x, y equals 3x minus 1. Okay. I'm going to go to the word problems because I do want to make sure that we get into 4H today. Number 7, I will warn you, number 7 gives you fractions as your answers, and that is okay. And you do have some homework problems that are going to have fractional answers. So I'm not going to go over number 7. You can do it yourself. I will tell you, if you're doing it yourself, the solution here is going to be 5 2/3 and 2/3. You might also write that as 17 thirds and 2/3, right? That would be your ordered pair. So if you do this one yourself, to check your work, those would be your solutions. And like I said, you will have some problems in your homework that will have fractions as the solutions. So I don't want you to think that we can only ever have solutions that are whole numbers. And if you get something that's not a whole number, oh, I must have done it wrong. No, you can have fractions. I just want to focus on the word problems because those tend to be what people struggle with more. But those are your solutions if you want to go back and do it on your own. Okay. All right. So with your word problems, there are some definitions that you need to know. And one of them have to do with complementary and supplementary angles. And these are relationships among angles. So complementary angles are two angles that when you add their sums, they add to 90 degrees. So if we were looking at a visual of complementary angles, if I had a right angle, which we mark with a little square in the corner, and I just draw a line here, I have angle A and angle B. Angle A plus angle B are 90 degrees, right? If we add their measurements up, and that means that angle A and angle B are complementary. Where supplementary angles are two angles that where you add their measured sum and it's their measured sum. When you add their measurements, it equals 180 degrees. So this comes from the fact that when we think about a straight line has an angle measurement of 180 degrees. So if I add in an angle here, and I'm going to call this angle C and angle D, angle C plus angle D equals 180 degrees, because those two angles, when I add them together, create that blue line. We're not going to test you on like actually drawing angles or anything like that, but you do need to know about these relationships so that you can solve the word problems that go with them. So number 8 says two angles are supplementary. So when you see that word supplementary, you want to go, oh, add to 180. Right? That's the piece we want to know. One angle measures 30 degrees more than twice the other. Find the measures of the two angles. So I'm going to say, okay, we have angle X plus angle Y equals 180. That relationship came from that first statement that the two angles are supplementary, right? If I were going to draw this, I would say, okay, well, this is angle X and this is angle Y, right? One angle measures 30 degrees more than twice the other. So what that tells me is that one angle is 30 degrees more than twice the other, right? It's 30 degrees more than twice that other angle, which we would write as X equals 30 plus 2Y. So now that I have my system, right? This is my system right here. I want you to solve this system and send me your answers for what X equals and what Y equals. This is Sam insisting upon being held. He'll just come over and like climb on her shoulder.
He wants treats.
He wants all the things. And then if he doesn't get pets, which was what he was doing right now, he does naughty things because he knows if he annoys us, then we'll pay attention to him. And so we have created very much a monster, which, to be fair, orange cats are monsters by themselves. See, he's like, I want up. Yeah. He will just climb right up. Nobody needs to see your butt. No. So we already have a variable isolated, right? So we can take the stuff that x is equal to, and we can plug that in for x in the first equation. All right, so we already have all this stuff here. So we'll go and plug that in there. So if we do that, we have 30 plus 2y plus y equals 180. So from here, we can combine like terms. So 2y plus y is 3y. And we can solve for y. So we'll subtract 30 from both sides. We get 3y equals 150. Dividing both sides by 3. We get y equals 50 degrees. Okay, go ahead and do that. I can't do this. I can't do this with you. Yeah. All right, so we have y equals 50 degrees. So going back, we have that the relationship that said x equals 30 plus 2y. So we're going to say x equals 30 plus 2 times 50. Now, one thing you can look at this and go, well, Aaron, we don't have to use that equation, right? We know that x plus y has to equal 180. So you can just subtract 50 from 180. Right? If you look at, oh, well, we know that to be the case. We know that y has to equal 130. Okay. Sometimes we get into the habit of like, oh, well, we have to go back and look at that first equation where the variable is already isolated, and we can only do it that way. Remember, we want to use our reasoning skills here too, right? We have two angles. When we add them up, they equal 180 degrees. So you don't always have to go back to that one equation where the variable was already isolated. If you did, right, we know that we have 30 plus 2 times 50, which is 100, and I get 130 degrees again. Which I wrote these backwards, didn't I? This is what happens when my cat's bugging me. I end up making mistakes. I apologize, everyone. There we go. Now, when you have a homework problem like this, and it's when you're putting these in, you're going to answer it with, you want to make sure you like put the angle measurements where they're supposed to go. And so you're going to have the smaller measurement is, or the smaller angle is blank and the larger angle is blank. So make sure you're paying attention to how you're entering them, so that you don't swap them and have it like mark you wrong. And then you get frustrated and you're like, I don't understand what it's mad at me. Just make sure you're putting them in the right spots. Okay. So I'm going to skip number 9, but we're going to look at number 10. Okay. And so it says, Molly ordered a poster printed from her prize-winning photograph. The poster had a perimeter of 100 inches, and the length was 6 inches more than the width. Find the length and the width. So there's some pieces of information we need to know here. So it's a rectangle. That's important. Oh, geez. So rectangles have lengths and they have widths. When we think about the perimeter, that is the distance around it. So the perimeter is equal to 2 of the lengths plus 2 of the widths. Now we know that the poster has a perimeter of 100 inches because it tells us that. So we can replace that P with 100. So far, we have one relationship here. We have 100 equals 2L plus 2W. The second piece comes from this statement where the length is 6 inches more than the width. The length is 6 inches more than the width. So now I have two equations. this one, and this one that I can use to solve, to find the length and the width for this poster. So I'm going to let you solve this system now that we have it set up, and send me your answers in direct message, please. Okay, so we know what the length equals. The length is 6 plus W. So we're going to plug that in for L, right? So plugging that in, I'm going to have 100 equals 2 times 6 plus W plus 2W. So once we plug that in, we're going to distribute like we have been. And combine like terms. And now we start to isolate, right? So we'll subtract 12 from both sides. So 100 minus 12 is going to be, what, 88? Divide both sides by 4. And we get 22 inches is equal to the width, right? So if we know what the width is, we can find the length because we know that the length is 6 more than the width. Therefore, the length is going to equal 28 inches. So our dimensions are 28 inches by 22 inches. And again, in your homework, doesn't look like, I don't think, maybe it's a quiz question. Anyways, you just want to make sure that you put the right numbers in for the spaces, right? So it'll probably say the length is, the width is, and so you want to make sure that you put those in the right spots. Okay, like I said, I wanted to touch on 4H today because I want to make sure that we're not getting off schedule. Before I touch on 4H, if you were not in class yesterday, make sure you watch the recording from class yesterday. It's already up on Eagle Online. because I went over your flight project, which is due on Monday, okay? The flight project is based on the work we did in 4E and using Google Sheets to do linear regression. And so I wanted to make sure that I touched on that. The whole reason we don't have a homework assignment for 4E is because we have the flight project. So make sure that you work on that this weekend. Like I said, it is due Monday. My goal tomorrow is to grade all of the projects that I am back behind on. So I should get those done tomorrow. So just wanted to give you a heads up on that, okay? So switching to 4H, this is something called the elimination method. And this will feel a little weird at first because we're not used to adding and subtracting equations, but that's basically what's happening here. So the elimination method is also referred to as the addition method in your homework. I just want to make sure that you're aware of the two terms. They mean the same thing. And so we do have a verbal description of how to walk through this. I'm going to read it, but again, it makes more sense once you actually like get into it and do it. So where in the substitution method, you want to isolate a variable. In the elimination method, you want to get all the variables on the same side. So it says get both variables on the same side of the equal sign for both equations, and the constant terms, that's usually where it's like 2x plus y equals 3. That 3 is the constant term. You want to get that on the opposite side of the equal sign. You're going to choose one variable to eliminate. Usually it's pretty apparent which one you want to use, but not always. You want to multiply by an appropriate constant if necessary, so the coefficients are opposites and the sum of those variables when the equations are added together becomes 0. So this step right here, step 2, what it's trying to get you to see is, let's say I have x plus y equals 4, and then I have x minus y equals 5. You see how these two variables, the y terms, have opposite signs? One's plus y and one's minus y. What we're actually going to do is we're going to vertically add those equations up. And if I vertically add them, I'm taking x plus x, which gives me 2x. The positive y, negative y, they cancel out. And then on the right-hand side, 4 plus 5 is going to equal 9. And what I've done is eliminate the y variable. So it's kind of like the substitution method in terms of like you're trying to get rid of something, but in some cases, this is the better method to use over the substitution method if you say already have your variables opposites, okay? So that at its heart is what is happening in the elimination method. From here, we would solve for x by dividing both sides by 2. That gives us a not very nice fraction of 9/2. But you then take that solution, plug it in for x in one of the two equations, and solve for y. So let's deal with nicer numbers because it's really difficult when you have fractions, I know. Just to remind yourselves, what are the types of solutions we can have? We can have the one solution, which is that nice ordered pair. We can have no solution, which is that redundancy, right? This is the same thing with the substitution method as it is with the elimination. If you get down to something like 0 equals 1, that's a no solution type situation. Or you can have the, it's the contradiction is 0 equals 1 versus the redundancy is when we get 0 equals 0. And that's where an infinite number of solutions. So when I look at number 1, I have 2x plus y equals 7 and x minus y equals 8. I already have that plus y minus y situation happening. So when I see this, personally, I go, oh, let's use the elimination method. It's already set up for it. It's going to work great. So what we're going to do, I'll rewrite the system so that they kind of line up nicer. So I've got 2x plus y equals 7 and x minus y equals 8. Again, I've already got this set up, so I have a plus y minus y. This wouldn't work if it was plus 2y and minus y, right? They have to be the same value, just opposite signs. So I'm going to add the two equations together. 2x plus x gives me 3x. Plus y minus y, those cancel out. We'll bring our equal sign down. And 7 plus 8 equals 15. So when it's already kind of set up for you, this is the fastest method in terms of like solving for that ordered pair, that system, right? Because you just add them together and suddenly, oh man, look at that. We don't have a y. We already are at an equation where we only have one variable. We just have to isolate that. So we'll divide both sides by 3. And I get x equals 5. Great. Looking back, the one thing that I hear from students is like, well, great, now I don't have an equation where my variable is isolated. Okay, but at least the first step was fast, right? And we're not going to always have it be easy all the time. So I have x equals 5. Looking at my two equations, it doesn't matter which one I plug it into. I'm going to actually choose the first equation because I have 2x plus y. So when I go to solve for y, I don't have to worry about dividing by a value or anything. So if I do that, I'm going to do 2 times 5, right? I'm taking this and I'm plugging it in for x right here. Let me let my board catch up. So I have 2 times 5 plus y equals 7. So 2 times 5 is 10. 10 plus y equals 7. We'll subtract 10 from both sides. Bring that variable down, and I have y equals -3, right? We know it's -3 because 7 minus 10 is going to be -3. So my solution, that's not how you spell solution. Is going to be the 0.5 -3. So that is the elimination method. Now, we're not always going to have it be set up perfectly for us to begin with, okay? So if we go to the next page, number 2, if I was given this problem in number 2 and was told, solve it however you want, I'm like, all right, great. I'm using substitution because it's already set up for me that way, right? But we don't have the do whatever you want option. We're saying, no, we're going to practice this elimination. So as I said before, remember, one of the first things you need to do is make sure your x and y's are on the same side of the equal sign. So I'm going to move that 4x from the right-hand side to the left-hand side. So what that's going to look like is -4x plus y equals 3, right? It was positive 4x on the right-hand side. When I moved it to the left-hand side, I subtracted, and then writing that second equation below, I have x minus 2y equals 8. So one of the things I noticed here to start with is my x and y's, they already have opposite signs, but they don't have opposite values. And what I mean by opposite values is that I have a -4x, but a positive x. So if I were to add those two equations together, the x's aren't going to cancel out, right? Just like with the y's, I have plus y and minus 2y. So when I add those together, they're not going to cancel out, okay? It doesn't matter which variable you eliminate first. It really doesn't. It's whatever you want to do. I tend to just go, okay, well, let's get rid of x first. Not for any reason other than it's the first thing I see. So if I decide I want to get rid of x first, looking at this equation here, I need to have the opposite of -4. And the opposite of -4 is +4. So I'm going to take this second equation, I'm going to multiply the whole thing by 4. Why am I doing that? Because when I multiply x by 4, it creates a positive 4x, which is the opposite of that -4x. So if I distribute this through, I'm going to get 4x minus 8y equals 32. Again, we have to do it to every single step. Why did I do this? Because it's going to work with that first equation. That first equation, if I bring that back over, I'm going to have negative 4x plus y equals 3. So now when I add the two together, negative 4x and positive 4x, they're going to cancel. So I don't have an x anymore. Plus y, negative 8y. When I add those up, I get negative 7y. And 3 plus 32 is going to make 35. So from here, I can divide both sides by negative 7. And 35 divided by negative 7 is going to make negative 5. So now that I have my y variable, I can go back to any of the equations. So when I say any of the equations, I've got equation 1, equation 2, or this new fancy equation 3 here, that I can plug that negative 5 in for any of those y's and solve for x. It does not matter, okay? I'm just going to go with equation 2. So I'm going to take this and I'm going to bring it over and plug it in here. So I'm going to have x minus 2 times negative 5 equals 8. Remember, if you are somebody who makes the mistake a lot where you're multiplying that minus 2 times negative 5 and you forget that that's a positive 10, maybe take that extra step to rewrite it as x plus negative 2 times negative 5. Which means we're going to have x plus 10 equals 8. Subtract 8 from, or subtract 10 from both sides, excuse me. And I get x equals negative 2. Let my board catch up. So rewriting, I'm going to have my solution is the point negative 2, negative 5. Okay. I'm going to wait and do 2, or wait and do 3 and 4. If we go to the next page, we're going to look at number 5, right? This one right here. And I want you to try number 5 yourself. You will get a solution. So think about what you would need to multiply by to get those to cancel out, right? I want you to practice that elimination method, and then send me your answer in a direct message. So when I see this, I see x minus y equals 3 and x plus 4y equals 3. So in my brain, I'm seeing, oh, minus y plus y. I know it's plus 4y, but they're already opposite signs. So if I have that type of situation, I like to take advantage of it so I'm not trying to multiply by a negative value. So my choice here would be to eliminate the y variable by taking this first equation and multiplying it all by 4. So if I do that, I'm going to have 4 times x minus 4 times y equals 12, right? I'm multiplying each of these terms. If I take this second equation and bring it over, I can now, oh, let me let this catch up. I don't know why sometimes it's faster pairing than others, but okay. So now I've got that minus 4y, positive 4y, so I can add them together. 4x plus x makes 5x. 12 plus 3 is 15. So I have 5x equals 15. Again, what happened to the y's? Well, we made them disappear because we intentionally created values that were opposite from each other, right? Negative 4y, positive 4y, they cancel. So we'll divide both sides by 5 and then get x equals 3. So it doesn't matter, again, which equation you choose. Any of them are fine. I'm going to go with the second equation because there's no negatives. Basically, that's the only reason why that's the one I'm choosing. So if I plug 3 in there, I'm going to have 3 plus 4y equals 3. Subtracting 3 from both sides, I end up with 4y equals 0. Again, this is valid. Dividing both sides by 4, and I get y equals 0. So my solution is the point 3, 0. All right, so we will pick up in 4H when we come back together on Tuesday. Again, don't forget, you've got, ooh, sorry, I just got a chill. You've got your project due Monday. Make sure you watch that lecture that I posted for yesterday, okay? And then what else do we have? I think 4F's homework is due tonight. I think.
Might be due tomorrow.
Is it due tomorrow? Yes. So 4F is due tomorrow. I know that our schedule for some reason says 4E is due today. I was just getting into the habit of like writing all it out. So again, there's no homework for 4E. The homework is the project, the flight project, which is due on Monday. So any questions for me before I let you go?
I'm good.
All right. Well, I
Thank
hope
you.
everybody has a great weekend. And I will see you on Tuesday. If you have questions about the project, email me, okay?
Okay.
Thank you.
All right. Bye, everyone.
Bye.